Welcome to Pradeep Sir classes as PSC, and today we are in the numerical king series AC Verma solution chapter number 29 and question number 40. And students, first of all I want to say you that all the concepts related with that particular numericals is electric field. What is about electric field? And when a charge is kept within a region, then it creates an electrical field. That is, if a test charge is placed within the field, then the like charge repel each other. That is, the test charge can experience an electrical influence along this direction. Okay, so the electric field intensity at that point, we can calculate the magnitude with the formula E equal to 1 by 4 pi epsilon naught q by r square, where epsilon naught is the permittivity of the free space. Okay, and the next one is the component of force. That is, when a force is acted along a particular direction, that we can resolve the forces along two perpendicular directions. That is f cos theta obviously, and that is f sin theta. And the third one is integration. A little about integration, that is like integration of sine theta d theta, this is equal to minus cos theta, or integration of cos theta, this is equal to sine theta. And what are the different types of integration? That is indefinite and definite integration, when we can apply a particular limit. That is definite integration, suppose integration of sine theta d theta, and if there is a limit 0 to pi, then you can say that this is definite integration. Okay, so let's start with chapter number 29, and again I say welcome to Pradeep Sir classes, where Logo can talk the physics. Okay, so let's start with question number 29. And yes, last of all, extra information is given, that is chapter 30. The numericals of all the numericals of related with chapter number 30 are completed, and you can follow playlist to achieve and to grab the concepts related with chapter number 30, that is Gauss's law. So students, let's start with the question number. First of all, students, write down the question and try, then see the answer. So question number 40. A rod of length L has a total charge capital Q is distributed uniformly along its length, and it is bent in a shape of semicircle. Find the magnitude of the electric field at the center of curvature. Okay, so question number 40, and it's a length. There is a length, and it is bent in the form of a semicircle, and the radius is capital R. If I take this one, that is the radius is, a rod is given, that is the length of the rod is capital L, and it is bent in the form of a semicircle, and obviously if I calculate, if I given some charge on it, suppose it is Q, then all the charges are distributed over the, if Q, capital Q charge is given to the rod, then due to the conducting property, it repels, all the charges are repel equally, and they are uniformly distributed over the wire. So the charges are distributed over the wire, and you can easily calculate lambda, that is total charge by total length, and this is called linear density. This is called linear distribution, or distribution of charge, or you can say that this is linear density. Okay, lambda, and here L is equal to, in place of pi r, you can write L. Why? Because the circumference of the circle is 2 pi r, and since it is a semicircle, then you can take the length as pi r. Okay, so pi r equal to L, and if students we take a small length dl, then it contains some charges, that is dq, and the dq is dq, or you can write as d capital Q, since it is capital Q amount of charge is given. So this is dl into lambda, lambda into dl. Okay, so lambda equal to charge density, charge density. So you can multiply lambda with the small elementary length, and this amount of charge dq can create a electric field along this direction. And if we place a test charge at that point, test charge means the negligible charge is called test charge. So what is a test charge? When the intensity of this, or it can create a small amount, a small region of field. So q naught, if we placed at that point, then we can easily calculate the electrical intensity, that is dE, along this direction. And if it is theta, then the elementary part makes an angle or subtend an angle of d theta. So it is d theta, d theta. So this is theta, and this angle is d theta. Again I say, a rod is bent in the form of a semicircle, and capital Q amount of charge is given to this rod. So the density equal to total charge by total length, and this is called linear distribution of charge, and you can say that pi r equal to L, and the charge content within this elementary length is lambda into dl. So dE, and this is theta, this is a vertically opposite angle, so electric field along this direction is dE sin theta, and along this direction, since this is related with theta, so this is dE cos theta. So dE sin theta, and if we take a similar dl amount here, then it can also exert an electric field of same amount dE, and since this is theta, so this is theta, and this is theta, and it is along this direction, it will be dE sin theta, and along this direction it is dE cos theta, and dE cos theta and dE cos theta cancel each other. So all the electric field, the net electric field, it comes from all the components that is directed along this direction. So dE sin theta, and you can take an integration of from 0 to pi, 0 to pi, that is 180 degree, 0 to pi. So dE equal to, students, 1 by 4 pi epsilon naught, and dq is the amount of charge here by r square. So this is the radius r square dq, and sin theta. So sin theta, this is sin theta. So integration of this, and 0 to pi is the limit. Okay, I think you can understand the concepts. And the next one is, you have to integrate this one, and we reach the conclusions. Okay, that is, what is the electric field intensity at the center of the semicircular portion? That is 1 by 4 pi epsilon naught. You can take a common of this amount, since it is a constant value. So 1 by 4 pi epsilon naught, in place of dq you can write lambda dl. So lambda into dl, lambda dl by r square, it is also a constant value, and lambda is also constant, so this is 0 to pi, and here it is lambda, and this is dl and sin theta. What is lambda? What is dl? So this is the amount of dl, and it can subtend an angle of d theta. So from the definition of angle, students, angle equal to arc by radius. Okay, so arc means dl, this is the dl, and this is radius. So arc by radius, or you can write in place of dl r d theta, r d theta. So in place of dl you can write r d theta. So r is a constant value, then 1 by 4 pi epsilon naught lambda by r, because r and r cancel this one. So sin theta d theta means cos theta, and the limit is 0 to pi. Sin theta means minus of cos theta, minus of cos theta, minus of cos theta. This is, so the answer is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught and lambda by r, and minus of cos pi, and again upper limit minus lower limit, there is minus minus plus, and then 0 degree. So cos pi equal to, students, this is minus 1, so 1 by 4 pi epsilon naught lambda by r, and this is minus and minus plus 1 and plus 1, so it is plus 2. So this is plus 2 and 1 by 4 pi epsilon naught, then lambda, 2 lambda by r. So this is the final answer, and you can modify it with the concepts of, in place of lambda you can write q by l. Okay, so q by l, and you can write, so this is the answer, and the electric field is 1 by 4 pi epsilon naught 2 into, in place of lambda you can write q by l, and in place of pi r, so this is r, and in place of pi r you can write l, since this is semicircular portion. So this is pi r and this is equal to length. So in place of pi r you can write this one, so 2 and 2 cancel this one, so 1 by 2 epsilon naught, 1 by 2 epsilon naught, and then pi r means l, so this is q, and this is l into l square. So this is the final answer, and you can check it. Okay, so the last, so the answer is, this is the answer. So when a particular length is bent in the form of a semicircle, and you have to calculate the electrical field intensity at the center of the loop, then you have to obviously take a smaller portion of this elementary, smaller portion of the semicircular part and calculate the electric field at the center, then integrate it by all the components along both the direction. There is a mirror symmetry, you can calculate the electric field at the center. Okay, so thank you, students, and wait for the next concept, that is 41 to up to 75. Okay, and by one we can easily calculate, we can easily analytically explain all the numericals. Okay, so thank you, and continue your study.